Hello, it's Professor Sims, and today, Sims slays simplifying radicals. We have two methods to simplify radicals. Today, we want to use our perfect squares. So let's recall our perfect squares, at least our first 10, which were what? 1, 4, 9. And of course, we're getting these with what? 1 times 1, 2 times 2, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, 7 squared, 9 squared, and 10 squared. So let's say if we had, let's start off with just the square root of 25. Now, 25 is a perfect square, and the square root of 25 is 5. Why? Because 5 times 5 is 25. And of course, once we have the square root of 25, our answer is 5, the radical is gone. Now, what happens if I have the square root of 50? 50 is not on the perfect square list, but let's simplify it. To simplify it, let's find the biggest perfect square factor of 50. And the biggest perfect square factor of 50 would be 25. So let's rewrite 50 with a factor of 25, which is 25 times 2. Well, 25 times 2 is the same as the square root of 25 times the square root of 2. Well, we said above that our square root of 25 is 5. We bring down the square root of 2, and we don't have to put our dot to represent our multiplication. We can write that 5 right in front of that square root of 2. So the square root of 50 simplifies to 5 times the square root of 2. Let's look at another example. Let's look at the square root of 27. Here again, let's find the perfect square factor, and we want the biggest one, the biggest perfect square factor of 27. That number would be 9. So let's rewrite 27 with a factor of 9. That would be 9 times 3. Here again, the square root of 9 times 3 is the same as the square root of 9 times the square root of 3. Well, what is the square root of 9? 3. And again, we can rewrite this without the multiplication symbol. So the square root of 27 simplifies to 3 times the square root of 3.